which is on polynomials. We have a long list of vocab today, lots of new terms to take a look at. Our first term is monomial. And a monomial is any single term. So if you remember that mono means one, then you'll remember that a monomial is a single term or one term. I've got 4 examples of a monomial. Any number is a monomial. Any variable by itself is a monomial. And any multiplication or division of numbers and variables and powers is a monomial. As soon as you see an addition sign or a subtraction sign, that's when it's no longer a monomial or a single term. To find the degree of a monomial, you will add the exponents on a monomial, even if the variables are different. So when we're looking at our example of negative 4xy squared, it has a degree of 3 because the power on x is 1, the power on y is 2, so the total degree for that term is 3. A polynomial is the sum or difference of monomials, and a polynomial is a generic term for any sum or difference of monomials, even if you only have 2 monomials that are being added or subtracted. Poly, you may remember, means many, so that's really the term that we use when we have a ton of terms being added or subtracted. And as we're going to see in our chart at the bottom of this page, it's also on page 487 in your book, so don't feel like you have to write that down. You could just make a reference to that. But we'll see that we also have special names for other types of polynomials as well. Standard form is the way that I want you to express your polynomial, where the degree decreases on each term from left to right. When you're writing a polynomial in standard form, you will choose one variable to look at the power on that variable. So when we're looking back at our example for degree, and we had that negative 4xy squared, if we had another term that was, say, 4x squared y, they would have the same degree. So we would choose one variable to organize it in order. And typically we choose the variable that's closer to the beginning of the alphabet. All right, so last year we have our chart. Again, that's on page 487 in your book. So don't feel like you have to write this down, but I'm going to go through. There's 2 different ways to name a polynomial. One is naming it using the degree or the highest power on any of the terms. So when we look through our polynomials, any constant, any number has a degree of 0 because you could think of that as being like 6 times x to the 0 power, because x to the 0 power is 1 and 6 times 1 is 6. So that's why the degree on a number or a constant is 0. So as you can see, the name using the degree is constant. That's because a number never changes. It's always the same. 6 will always be 6. It's a constant function. So we're going to take a look at just classifying them using degree, and we'll look at the end of the chart in a minute. Our next polynomial is 5x plus 9. So we have 2 terms. In order to find the degree of the polynomial, we look at the term with the highest degree. So our constant term, 9, has a degree of 0, but our 5x term has a degree of 1 because, as we learned in our last unit, any time a variable has a power of 1, we don't write it because x to the first power is x. And this would be called linear, and we saw that back in try 2, all of our linear functions. Our third polynomial has a highest power of 2. So our 4x squared term has a power of 2, our 7x term has a degree of 1, and our constant term has a degree of 0. So the highest power on any of the terms is 2, and that makes it a quadratic. Our fourth polynomial is 2x cubed, so we would call that a cubic function when it has a degree of 3. And our last polynomial there, 8x to the 4th, is the term with the highest degree, and that's a quartic. If you see a term that has a 5th power, you could call that a quintic. Beyond that, we just use the number, so it would be 6th degree, 7th degree, 8th degree, and so on. Now looking at classifying them by number of terms, and this is hopefully pretty self-explanatory if you remember what these prefixes mean. So as I mentioned, mono means 1, so a monomial is 1 term. Bi means 2, so a binomial is 2 terms. Tri means 3, so a trinomial would have 3 terms. If a polynomial had 4 terms, we could call it a quadnomial, but beyond that, I would just ask you to call it a polynomial. It's got many terms. All right, so here's the notes part of our video for today. We've got section 8.1a, which is polynomials. We have 2 objectives. I can classify polynomials. We're going to, again, be classifying them by degree as well as by number of terms. And then I can add polynomials and write them in standard form. So the first thing we're going to take a look at is classifying polynomials. Our first example, we're going to determine the degree. Then we will classify it by degree and number of terms. So looking at my first example, I've got 3x squared y. So to find the degree of this term, I will take the power on x, which is 2, add it to the power on y, which is 1, and get a sum of 3. So the degree of this term is 3. And if you remember from the chart, 3 is a cubic function. So classifying our first example by degree, we would call that a cubic. To classify it by number of terms, I don't see any plus or minus signs. So we have a single term, so this would be a monomial. So to classify it by degree and number of terms simultaneously, we would call it a cubic monomial. Our second example, we have 6d minus 8 plus 4d squared. So again, classifying it by degree, we would look at the term with the highest power. Well, our first term has a degree of 1. Our second term has a degree of 0 because I see 0 variables. And our third term has a degree of 2, looking at that exponent. So the highest power on a single term is 2, so that is a quadratic. And then looking at number of terms, we have 3 terms. The term for 3 is tri, so it's a trinomial. So again, classifying it by degree and number of terms simultaneously, it would be a quadratic trinomial. Our last example, we have 5m to the 4th, so the degree on this term is 4, plus 10m squared, so the degree on this term is a 2, minus 5m, if you don't see a power, remember it's a 1, minus 7, and the degree on the constant is 0 because we see 0 exponents. So, looking at the degrees of those terms, the highest degree is 4, and that is quartic. And number of terms, I have 4 terms. I would accept 2 answers if you can remember quadnomial. Or you could just call it a polynomial. So our 2 options to name it by degree and number of terms simultaneously would be quartic quadnomial or quartic polynomial. Our next slide, we're going to be practicing writing our polynomials in standard form. So our first example is 10x minus 2x to the 4th plus 4. Remember, standard form is when the power is in decreasing order. So we look at the degree of each of our terms. My first term has a degree of 1. My second term has a degree of 4. And my third term, I see 0 variables, so it has a degree of 0. So obviously my first term would be the 2x to the 4th term. Be careful that that negative sign stays in front of your 2. The negative travels with the 2, so it is a negative 2x to the 4th. That would go first. My next term would be the term with a degree of 1, so plus 10x. And finally, my constant goes at the end, plus 4. Our second example, the first term has a degree of 4. My constant term has a degree of 0. My third term has a degree of 2. My fourth term has a degree of 1. And my last term has a degree of 3. So writing this in standard form, again, looking through at that negative sign, it stays with the 5x squared. So as you rearrange, be careful that the negative stays with the term that it's in front of. So my first term is 7x to the 4th. My second term would be plus 9x cubed. My third term would be minus 5x squared plus 3x. And finally, my constant of 6. On our last example, looking through the degrees on these, my first degree, the constant of the the degree of the constant is 0. The degree of my second term is 3. The degree of my third term is 5. The degree of my fourth term is 2. And the degree of my last term is 1. So putting this in order, I've got a negative in front of my 5, so it's a negative 5x squared minus 12x cubed plus x squared minus 7x, and finally my constant plus 1. And the last example we're going to take a look at is adding polynomials. And you already know how to do this. This is just combining like terms. There are two different ways to look at combining like terms. One is adding it horizontally, the way that I have it set up on this slide. And the other way is adding it vertically, which is kind of how you first learned to add numbers when you stacked them on top of each other. So I'll show you both methods so that you can use the one that you prefer. And of course, I would always like your answer in standard form. So the easiest way to do that is to look for the terms with the highest power and add them together first. So looking at our first example, I see a 5c squared plus 2c squared. Remember, when we multiply powers, we add the exponents. That's what we learned in our last unit. When we add like terms, we do not change the power. We just add the coefficients. So 5 plus 2 is 7. So I have 7c squared, and then I have 3c minus 5c. 3 minus 5 is negative 2, so minus 2c. So that's taking a look at adding it horizontally, is you just look for your like terms and add them together. For those of you that need a little bit more structure, like I said, you can put them one on top of each other, line them up vertically. So again, line them up so that they're in standard form. My first polynomial, my first binomial, it's got two terms, is already in standard form, and so is my second one. So I'm just going to line them up the way that I see them. Then we draw the line, and then we can just add top down. So again, looking at our first term, we've got 5c squared plus 2c squared, so we combine that to 7c squared, and 3 minus 5 gives us a negative 2. So you will always get the same answer as long as you're combining your like terms correctly. It's just which method you prefer of organizing your work in order to see what the answer is. All right, so our next example, I think that lining it up vertically is probably a better way to organize it for most of you. So I'm going to go ahead and do that method with my next two examples. If you prefer the horizontal method, that's fine. That's what you'll take your notes on, is just adding them vertically. But what I notice is, when I want to line them up vertically, that I want my polynomials in standard form. So I'm going to put my 4d cubed first, minus 3d plus 6. Make sure that the minus sign goes with the 3d term. And then in my second polynomial, trinomial, I have 3 terms. I've got my 2d cubed plus 5d minus 3. So when I add these, and you can add in any order, but I might recommend just going right to left left to right, because that's how we read. So the 4 plus 2 gives us 6d cubed. Negative 3 plus 5 is positive 2d, and 6 minus 3 is positive 3. For our last example, what we need to be careful of is that the degrees on each polynomial don't match up. So when I'm looking at my first polynomial, putting this in standard form, I've got 5g to the 4th minus 2g squared plus 3g. Let's fix that real quick. My second one, when I'm putting this in standard form, I've got 5g cubed, and I do not have a cubic term on my first polynomial. So I'm going to kind of squeeze that between the fourth and the second powers. And then I've got a minus 2g squared plus 2g. So when I add these, my 5g to the 4th has no like term. neither does my 5g cubed. So I just kind of drop those down. There's no adding to do with those. The next piece, when I'm looking at this, is I will be careful about my adding. A negative 2g plus negative 2g. Remember, I'm adding these two polynomials together. You're digging yourself further in debt, so it is a minus 4g squared. They do not cancel unless they have opposite signs. And think about that from when we did systems. When we were solving by elimination, we wanted the same coefficient but opposite signs. Then they would eliminate. If they have the same sign and you are adding, they do not eliminate. And finally, 3g plus 2g gives me 5g. So that is our last example for this lesson.